This is Tiago from Coderversity, and in today's video I'm going to be teaching you how to master C# and .NET interviews with essential theoretical concepts and strategies. If you are interested in a more practical guide, please check my interview algorithms video in the description. In this video, you will learn the most important areas in the backend .NET and C# interviews that are composed by C# language fundamentals, in which I divided in three groups, which are data types, variables, control flow, methods and parameters. Then the second group is object-oriented programming in C#, that is composed by the principles of object-oriented programming, classes, interfaces and structures, access modifiers, and the third group is advanced C# concepts, which have delegates and events, LinQ, generics, and asynchronous programming. Then we proceed to the .NET Core Basics, which are composed by the ASP.NET Core Basics and dependency injection. Proceeded by design patterns in C#. We will be talking about creational patterns, structural patterns, and behavioral patterns. Next, we have unit testing with XUnit or NUnit. Also, we will have common C#.NET interview questions, behavioral questions, technical questions, and design and architecture questions. And finally, we will have interview preparation strategies on practicing code on online platforms, whiteboard interview tips, and time management in interviews. All of these groups will have sample questions and the respective answers, because there are infinite numbers of each group that an interviewer can ask. So I will be just leaving you the groups for you guys to check more or less what is asked, and then if you want to search more questions of that kind, you feel free to do it. So what are we waiting for? Let's dive in. Interviews often cover both theoretical understanding and practical skills, focusing on a variety of topics from basic language constructs to advanced patterns. The importance of mastering theoretical concepts is that you need a deep understanding that leads to better problem solving, efficient communication, and higher success during interviews. I'm going to use Visual Studio Code for the examples of the questions that I'm asking. So let's do it. So let's start with data types and variables. I have a sample question for you. What is the difference between value types and reference types in C#? So the value types are something like this. The value types store the data directly, while the reference types, for example, classes and interface, as the data type are like int, booleans, or structs, um, the reference types store a reference to the data's memory address. The value type are typically stored on the stack, whereas the reference types are stored in a heap. This distinction affects memory management and performance. So, having that said, what happens if I type this, put like this, and then print like this? So, here we have the value type, and here we are doing a copy of the variable a, and then we are assigning the value 10 to the value type integer of b, and then we are outputting the a. So what do you think the output will be when we write a to the console? Yes, indeed, outputs 5. Why? Because we don't change the value type of a. We only change the b. We do a copy of the value A to B, but then we reassign with the value 10. So if we were to output B, this would output 10. Next, the reference type. The reference type can be written like this, can be a normal class, and can be characterized by a value type of int with the name value. So if we instantiate an object one of the myClass type, and we attributed the value type inside of it to 5, and then if we do the same thing as before, myClass object 2 equals to object 1, this references to the same object. So both the reference types object 2 and object 1 reference to the same data memory address. And if we put object2 dot value equals 10, and then we put an object write line to the console, if we do this, what will be outputted? Reminder that we are writing the object 1 and not the object 2. Indeed, it outputs 10. And why is that? The object 1 has the value 5, but then we are saying that this reference is pointing to the same objects of object 1. So both object 2 and object 1 point to the same data address. So if we edit the value in any of them, that's the output we will get once we write its value to the console. Now, next sample question. What are nullable types in C#? A nullable type is represented like this. Nullable int equals null. So the nullable type has here a question mark. That means it can have the value null. The nullable types, for example, an int nullable type or a boolean nullable type, allow value types to represent null, like you see here. This is useful in situations like database operations, where a value can be undefined or missing. So, how can we manage that? If we do nullable int dot as value to check if the nullable object, not object, the nullable type has a value, then we can output the nullable int dot value. Otherwise, we can just say the value is null. These are some sample questions for data type and variables. Now, for the control flow. A simple question. Explain the difference between for each, and while loops in C#. So, let's type in a for. For int I equals 0. This will be my helper variable, and then until each iteration while di is less than 5, for each iteration we will increase a value of 1. A for loop is used when the number of iteration is known beforehand. So if we can do this, and then console.writeLine di. It's known beforehand because we need to tell where it ends. In this case, it ends when di is equal to 5. So it iterates while di is less than 5. And we are incrementing by 1. Then we can go to a for each. For a for each, we can declare here an array of numbers that will contain 1, 2, 3, 4, and 5. And then the for each, in which iteration value of the array, this is the array, and this is the value that each iteration will have while going through the array, and then we can do whatever we want here inside. So let's also put a console.writeLine number. A for each loop iterates over a collection or array, and you don't have to necessarily know where it ends. As you can see, we have no condition of stopping. We are just going through the numbers. And lastly, we have the while. The while loop continues to execute as long as a condition remains true. For example, while, actually, let's define here a count. Int count equals 0. And while the count is less than 5, we will do console.writeLine count. And then, if we just keep it like this, it will go forever because the count isn't changing, so the count will always be less than 5. So in order not to have an infinite loop, let's do count plus plus for each iteration, and it will continue until the count is equal to 5. Next, how does exception handling work in C#? So C# uses try, catch, finally, and throw for exception handling. The code in the try block is executed, and if an exception occurs, control passes to the appropriate catch block. Then, the finally block runs regardless of exceptions, typically for cleanup. So, we can do a try. Then, if an exception is thrown, we catch, let's say, the divide by 0 exception, and we do something in finally. So let's try int result equals 10 dividing by 0. This will cause an exception of dividing by 0. So, since it will recognize this exception, it will enter the catch block. And in the catch block, we can put whatever we want. We can treat the exception however we want. We can use string interpolation here to use variables inside the string and put error equals to the message of the exception. And regardless if it catches an exception or not, it will run console.writeLine cleanup code goes here. And lastly, for this group, we have methods and parameters. So What is the difference between ref and out parameters in C#? Ref C# can have like this written. Can be like this written. So if we put something like number equals to number plus 10, and we are getting the reference by parameter. So ref and out both pass arguments by reference. The ref, as you can see here, requires the argument to be initialized before being passed, while the out does not. The out is typically used to return multiple values from a method. So, for example, update ref, update out int number equals to 20. Now, if we do something like int a equals to 5, and we update ref of a, it means that a must be initialized before passing, like we are doing here. Then we pass, and then we can do an output of a that will output what? So we are passing the a, and then it will sum 10. So the output will be 15. The out parameter does not have to be initialized. So it can be used like this. And then we can console input console.writeLine b, as this does not need initialization. And then what will it output? We don't have initialization, so we don't have an initial value. Anyway, since we don't need initialization, the numbers will be 20. So this outputs 20. And that's it for data types and variables group. Next is object-oriented programming in C#. Stay tuned. So, for object-oriented programming in C#, we will start by the principles of object-oriented programming. So, as a sample question, explain the 4 principles of OOP with examples. The 4 principles of object-oriented programming are encapsulation, the bundling data and methods together, for example, using classes. So let's type in an example. We have the class person, that will have a private field which will be only accessed by this property, which has a getter and a setter. All of this is encapsulated. Why? Because you don't have direct access to the name. You have to pass through this getter and this setter, which can contain any business rule that you want. So you can't just edit this. You have this for safety. Next, we have inheritance. Inheritance allows classes to inherit properties and methods from a base class, for example, the derived class. So let's put a parent class called animal, which will have a method of eat, which is composed by a simple output saying eating. Then it can have multiple derived classes. For example, the dog, and this is how we represent the inheritance. Now, the dog can have also a method called eat, a different one. So when you use inheritance like this, you can always say that the derived class is a base class. In this case, a dog is an animal. Next, we have the polymorphism. Polymorphism allows objects to be treated as instances of their parent classes, for example, overriding method or interfaces. In this case, we can do something like this. We can say that this method from the parent class is overridable by saying virtual. Now we can do public override eat and then dog eating. What will this do? If we say, for example, animal A equals new dog, this is polymorphism. And if we type A dot eat, it will output the overridden method. In this case, the dog one, because we are instantiating a dog. This is method overriding. Next, the abstraction. The abstraction is hiding implementation details and exposing only necessary functionality. For example, abstract classes or interfaces. An example would be abstract class vehicle, where we have an abstract method called move. Notice that abstract classes can't be instantiated. They are mainly used to be inherited from. So for example, a class car is a vehicle. And then we can override the abstract method called move that currently does nothing, but now it will output moving. Actually, the car is moving. Next up, we have classes, interfaces, and structs. And for the next question, what is the difference between classes and structs in C#? The classes are reference types and support inheritance like we saw before, while structs are value types and do not support inheritance. Structs are typically used for lightweight objects like points or vectors. Here's a sample. Like you saw before, this is a class. Let's call another class point class. So this is a reference type. And we'll have an int x and an int y. Then Let's have a struct. Point struct. And this is a value type. And we'll also have a public int x and a public int y. So for the point class PC1, let's instantiate, and this is PC1, not OC1. Let's put x equals 10 and y equals 20. And point class PC2 equals to PC1. So as you can see, the PC2 points to the same memory address as PC1, so a reference type. So if we do PC2 dot x equals 30, and then we console dot write line PC1 dot x, this will output, you guessed it, 30, because it's a reference type. Now, if we do point struct ps1 equals to new point struct x equals 10 and y equals 20. And then if we do point struct ps2 equals to ps1 and ps2.x equals 30, since this is a value type, what happens if I put the ps1.x as an output? Of course, it will output 10, the value type. Next, we have the access modifiers. Let me start with a question. Explain the difference between public, private, and protected access modifiers. So, we can declare a class, or actually, let's do base class, and declare these properties. So, if we have a public access modifier, it means it is accessible from any part of the code. If we do private, it means it's only accessible only within the same class. So in this case, within the base class. And if we put protected, it is accessible within the class and it's derived class. Now, for the next group, let's jump to advanced C# concepts. On the advanced C# context, we will start firstly with delegates and events. So an example of interview question would be, what is a delegate in C# and how is it used? So let's create a file here for delegates and events. And a delegate is declared like this: delegate void print message. So a method. A delegate is a type-safe function pointer that holds reference to methods. Delegates are used in event-driven programming and to pass methods as arguments and implement callback functions, similar to reference type parameters. So we have our delegate that is called print message, and then we will declare, so this is the delegate declaration, and then we will have a method print to console string message that will console dot write line the message, simple method. So this method matches the string and delegate signature, as you can see here. And now we will use the delegates. Print message, that is the name of the method, print delegates equals to print to console. And then we just delegate hello world. And this by using this delegate. So the delegate points to the reference of this method, and when we use the delegate, it will automatically do things according to the print.console, since it's the same declaration and parameter signature. So now this will output hello world. Then we can jump to LinQ. LinQ is language integrated query. So a simple question. How does deferred execution work in LinQ? So if we do something like a collection of list type with 1, 2, 3, 4, and 5, and we use LinQ to query numbers dot where the n has to be higher than 3. This is where the query is defined but not executed. Why is it not executed? Because deferred execution means that the LinQ query is not executed when it's defined, like in here, but only when the result is accessed, like through an iteration or calling methods like toLists when we enumerate the results. So a code sample for this would be like we have here, and then we will make use of the result by accessing it using a for each var number in our query, and then we just console.write line number. So this is now used and executed, and this will output, of course, 4 and 5, and this is a deferred execution. Now let's go to the next point. The next point is asynchronous programming. Let's create a file for that. Async programming. So regarding async and await, a simple question: what is the purpose of async and await in C#? The async keyword marks a method as asynchronous, like if we do async task int get number async, we are saying that this method is asynchronous, allowing it to run on a separate thread without blocking the main thread. How do we make use of it? By calling await on an asynchronous operation, and this will delay the thread on 1 second, and we are using this to simulate the async work. So the await keyword is used to pause the execution of the method until the awaited task is completed, in this case the delay. Then we can return anything. Let's return 42, for example. And we can call this async method. Let's call it async method, and then int result equals to what? Since it's an asynchronous task, of course, await get number async. It's a good practice that on asynchronous methods we always end the method name in async. And then we console.writeLine results. So another sample question would be, how do you handle exceptions in asynchronous methods? So exceptions in asynchronous methods are caught using try-catch blocks, just as in synchronous methods. If an asynchronous method throws an exception, it is propagated to the caller as part of the return task. So instead of doing the getNumberSync, let's call getNumber with error async. And we do this, and instead of returning, we throw a new exception. Exception called, not called, with the message an error occurred, just to simulate. And then in this method, let's surround it with a try catch. And int result will be the call of this method with error. And then we will catch an exception ex. And then we will console writeLine the x.message. And then this will output an error occurred. Simple, right? Just as in synchronous operations. Now, the .NET Core basics. So, let's say an interviewer asks, what is a middleware in ASP.NET Core and how does it work? Let's create a file. .NET Core basics. And let's understand it. A middleware in .NET Core is a software that processes requests and responses. Each piece of middleware in the pipeline can process the incoming requests, modify it, or pass it to the next component, allowing for modular request handling. Let's build one. Public class, custom, middleware. Let's have a private read-only request delegates, that by now we know what they are, and the constructor that receives request delegate next and applies to the next field, the private field, and then we always have an async task invoke async that will receive by parameter our HTTP context, so within a request, and then we can do whatever we want here. So console.writeLine request processing to simulate the processing, and we will execute the delegates that we receive, the context by parameter. This will apply our delegate function, and then we can console.writeLine response processing. Then we need to add the middleware to the pipeline in startup.cs or program. So we declare a method public configure, and we will receive the application builder app, and then we will say that this app will use the middleware of the type custom middleware, and then run asynchronously the context by awaiting the context.response.write async hello world, so that we can just call this configure method in the startup.cs. So here, like I said before, we are adding the middleware to the pipeline in startup.cs or program. And this will execute the invoke async, and our delegate will be the write async and hello world. Then, how does dependency injection work in ASP.NET Core? So ASP.NET Core has built-in dependency injection, DI for short, to provide services to classes that request them via constructor injection, reducing coupling between classes and their dependencies. So we always use interface iMessage service string get message. An interface is a contract in which the object that implements the interface has mandatorily to have an implementation for the methods declared there. Then we can declare a public class message service that implements the iMessage service interface or contract, and will implement the get message that will say hello from the service. This just returns a string. Then a public class where we will use it, the home controller, for example. And then we have a private read-only iMessage service, message service. So we say that in this controller we have an entity that for sure implements these methods, in this case the get message. So whenever we put an interface like this, we know that when we say the constructor receives an interface of that type, the dependency injection will make sure that we'll have the instance that implements it, in this case the message service. So this is the pattern used. We declare a field and then we receive it by parameter the interface, and then we just apply to our private field, or public, can be public as well. And then let's create a method of an action for the index where the message is retrieved by our entity that implements the message service. And then we can return as content the message. This is just an example of a controller. You can use it in a service on a repository class or wherever you need. And then to register the service in startup so that it knows what to instantiate when we receive this interface by parameter, we just say public void. This is in startup, don't forget, or program, configure services, where we will register in our iService collection. And we say service.add transient. We will choose a transient life cycle for the entity when it's instantiated. that the interface will translate in an entity of the message service. So and this is services. So whenever the services detect that we in a constructor are receiving an interface of this type, it automatically instantiates when needed according to the lifetime the corresponding concrete entity. Now a very important one, and a lot of requests in interview are made regarding this, are the design patterns in C#. Let's create a file for that, design patterns. So let's start with creational patterns. Sample question. Explain the singleton design pattern with an example. So the singleton pattern ensures that a class has only one instance and provides a global point of access to it. In C#, this is typically implemented by using a private constructor and a static property to hold the instance. So let's create a class singleton. And the private static instance, and then we create a read-only object lock so that we can deal with concurrency, because this will be the only object within the global scope. So we have to be very careful with the access to it. Thus the lock. Private singleton, the constructor, and then a static method for the instance, where we have the get that will use the lock. So we will lock our lock, and if our instance is null, then we will provide a new singleton, and then return the instance. So if the instance is not null, we don't create, we just return. Now we can do something by doing like public void do something, just so that it has a method and it's more explainable, so that it makes a bit more sense for a class to do something. Console write line singleton instance is working. So there you go, that's how you implement a singleton. Next, for the creational patterns. What is the factory method pattern and when would you use it? So a factory pattern method pattern provides a way to delegate the creation of objects to subclasses, allowing greater flexibility when the exact type of object is unknown during runtime. So I will do the code. Let's use the interface iProduct, and let's say we have a method that returns a string and gets the name. Then we will have the concrete class that will be the public class concrete product A that will implement iProduct. And this will of course have to mandatorily implement the get name. Let's say product A. And now let's do the same thing, but for product B. And now let's do the creator abstract class, like public abstract class creator, public abstract I product create product. And now let's do the concrete creators. Public class concrete creator A, that is a child class of the creator, a derived class, and we will override the I product create product that will create an instance that implements the I product. And since we are in the concrete creator A, we will of course return new concrete product A. And then we will have a creator for B, creator for product B instance. And then how to use it, the factory method. We call a creator that can be a concrete creator A, and then a product that is generated by the creator, create product. And if we do, since we are using the concrete creator A, since we are going to do console.writeLine product.getName, and what will it output? It goes to the product created, that is from a creator factory for the product A. So this will output product A, because this is what it does. Now, a structural pattern. What is the adapter pattern and when would you use it? So, the adapter pattern is used to allow incompatible interfaces to work together. So it involves creating a wrapper class that translates the interface of a class into another interface expected by the client. So let's create the target interface by the client. Let's call it iTarget. That does some request. And then we will have the adaptee class that will do a specific request, and this request will reflect in a console.writeLine specific request. This can be any logic that you want. And now we will have our adapter that will implement, of course, the iTarget, the target interface. And we'll have the constructor that will receive the adaptee, and we will initialize our adaptee with it. Then we will do the request that we want. So we will have the adaptee for a specific request. So this adapter, it's like an enabler, an intermediate class that will implement the targeted interface, and then we can do the other interface specific request by receiving it by by parameter in the constructor. And then when we call the request, it does the specific request that is owned by the adaptee. Now, how do we use it? target equals to new adapter, new, and the instance of the adaptee, and we simply call the target.request, and this outputs specific request, like in here. There you go. Another important one would be the decorator pattern. So let's explain the decorator pattern and provide an example in C#. The decorator pattern allows you to dynamically add behavior to objects by wrapping them in decorator classes that implement the same interface. This is useful when extending functionality without altering the original object. So this is a bit similar to the adapter in terms of code. We will have a public interface iComponent that does an operation of some sort. Then we have the concrete components that we will call concrete component, and we'll implement the iComponent interface, and we'll also do a public void operation that will simply, again, write concrete component operation. Then let's do the decorator base class. Public abstract class decorator iComponent that will have a protected iComponent entity that will implement the iComponent interface. Then the constructor for iComponent, we will simply apply the objects and of course do the operation that will be virtual in order to be overridden. Component.operation. So this will use the operation from the base class, and then we will have the concrete decorator with, of course, the constructor, not component, decorator, and we'll receive by dependency injection a component, and we'll transfer to its base class the component, and then we will use the override operation and not only do the base class operation, but we'll also add the added behavior that will be here, a private void added behavior console.writeLine added behavior from decorator. So this will not only override the operation, but it will use it as well, the base operation. It will not remove the operation at all. It will do the base operation and the added behavior. How can we use this? We do component, a new concrete component. Then we will have another component that is the decorated component. That will be a new concrete decorator with the component by parameter. And then we just do both operations by just calling operation. And there you go. Now, and lastly, the behavioral patterns. So, describe the observer pattern and provide an example in C#. The observer pattern defines a one-to-many relationship between objects so that when one object changes state, all its dependents are notified. It is commonly used in event handling systems. So let's say you are subscribed to a magazine, and whenever a new magazine is released, all the subscribers that subscribe to that magazine will receive it. That's more or less the observer pattern behavior. So let's do it. Let's put it in practice. Let's create a subject and then private list of observers. Let's say the subscribers equal to a new list of observers that will be empty at the beginning. Then we will declare a method to attach an observer and then we will just add to the list. We will do the same thing for detach. And instead of add, of course, we remove. And a notify so that when an update is made on the observers, every subscriber will be notified. And this will do observers dot for each we will update the observer with any code that we want. And of course, we will have a state of the subject. Next, we will see the observer interface. Public interface I observer. That, well, what will be the function of it? Of course, the update. It will be the only thing that the observer will do. Then we will have a concrete observer. That will implement, of course, the I observer. And we'll have a private read-only subject received by parameter here in the constructor. And we will assign to it. And when we assign a subject to an observer, what will we do? Of course, we will attach this same object. Subject dot attach what? The concrete observer, of course, this instance that that is represented by the this keyword. And then we have to add some logic on the update. What will be the update? Again, a simple console write line that will have the observer subject state is now, and then we will do subject dot state. So our update will be just informing our state. Let's use the observer pattern. So we have a subject, then we will have, of course, a concrete observer. Let's call it O1, new concrete observer. And then, of course, we have to pass our subject. And then let's change the state of the subjects. In the example that I made for the magazines would be a new release, but in this case will be state 1. And then the subject just notifies all the observers. So this outputs observer subject state is 1, like here. And there you go, you have an implemented observer pattern. Now that we have our practical part, let's say like that, of this theoretical interview done, let's check some interview preparation strategies. So let's say, how do you handle a coding problem that you are unfamiliar with during an interview? Interviewers assess how candidates approach unfamiliar problems. In this situation, verbalizing your thought process, breaking down the problem, and making educated assumptions can demonstrate your problem-solving skills, even if the solution is not immediately clear. And don't forget, asking questions can be really valuable. That makes the interviewer think and understand that you are putting various scenarios in the table that you might need for your implementation. So also, continuous learning is essential to stay updated with new C# and .NET features, especially in an evolving technical landscape. Some common C#.NET interview questions would have maybe behavioral contexts. So let's say an interviewer asks, describe a time when you solved a complex problem in C# and how you approached it. Interviewers are looking for how you approach problem solving, including how you break down the problem, communicate, and collaborate with team members. Also, regarding technical questions, let's say, how would you optimize the performance of a C# application? Consider things like memory management, algorithm efficiency, and use of async programming to prevent blocking operations. For design architecture questions, how would you design a scalable RESTful API in ASP.NET Core, for example? Discuss the use of design patterns, dependency injection, error handling, and performance considerations, for example, caching or load balancing. And how do you handle like practice codings on online platforms? You can use platforms and practice like in LeetCode or HackerRank or Code Wars to practice. Also, some whiteboard interview tips: you can communicate clearly while coding and explain your approach as you write it down. That will be very valuable. Also, for the time management in interviews, you prioritize simpler parts of the problem first, and then you keep an eye on the clock to ensure that you are making steady progress. So, like I said before, continuous learning is essential to stay updated with C# and .NET features, and reviewing concepts and practicing coding regularly is a key to master interviews. And with this, it wraps up our tutorial on mastering C Sharp and .NET interviews in a theoretical way. I hope you found this project helpful and that you learned something new along the way. If you followed along, congratulations on completing the project. Don't forget to like this video if you enjoyed it and consider subscribing to the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.